Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon to all of my students. So now you are watching the third video for chapter 2 function. So in this video you are going to learn the third subtopic, which is 2.3 quadratic functions. Okay, our learning standards for today. So 2.3 quadratic function. So by the end of this video you should be able to analyze and make generalization about the effect of changes of a, b and c in fx is equal to ax squared plus bx plus c. So this is the changes we want to learn about the changes of a, b and c. Okay, towards the shapes and position of the graph. In secondly, you will be able to relate the position of the graph of quadratic functions with type of roots. And lastly, you should be able to relate the vertex form of quadratic functions fx is equal to a x minus h square plus k with other forms of quadratic functions. Okay, before we move to the lesson, please observe this real life example. Okay, a ball is thrown into the net. What can you observe from the path of the ball here? Okay, if you observe the path of the ball, it follows the shape of parabola. Okay, the path or the curve is the shape of the graph of quadratic function. What are the other examples that involve the shape of a parabola? Okay, so this is another example. The dolphin jump back into the sea. So it forms a shape of a parabola. Okay, this is a roller coaster, right? So so it also forms a shape of parabola. Okay, analyzing the effects of changes of A, B, and C towards the shape and position of the graph for fx is equal to ax squared plus bx plus c. Okay, the general form of quadratic function. Okay, this in the form of fx is equal to ax squared plus bx plus c. So this is the general form where a, b, and c are constant and a cannot be 0. Okay, if a here is 0, so there's no a 0 plus bx plus c, so the highest power is no longer 2. That's why it cannot be 0. The shape of the graph of quadratic function is a parabola which is symmetrical about the axis that passes through the minimum point or maximum point. Okay, this is the first example. Okay, graph senyum when a is more than 0, the value of a is positive. Okay, so this is the axis of symmetry, and the lowest point here we call it as minimum point. Okay, this is the example of graph a less than 0, negative value. So graph masam. So this is the axis of symmetry, and the highest point we call it as maximum point. Okay, the highest power of a quadratic function is the same as the higher power of quadratic equation, that is 2. Here, highest power must be 2 for quadratic function and also for quadratic equation. Okay, let's see this activity. You can try by yourself here, scan this barcode or go to this link and you can move this one. The first one is A button, the second one is B button, and third one is C button. You can move your cursor to the left and to the right and observe the changes. Okay, now I record and please observe these changes. Okay, I move the cursor. This one just now A to, okay, this one is A positive. Okay, then now I move B. Okay, to the left, to the right, to the left, to the right. And lastly, C, upward, downward, upward and downward. Okay, the intercept, y-intercept is different. Okay, so changes in shape and position of the graph function ax squared plus bx plus c. Okay, if only the values of change, if only the value of A changes. So what happened? The change in the value of A affects the shape and the width of the graph. However, y-intercept remain unchanged. Okay, so y-intercept does not change, but it only affect the shape. The shape whether it is smile or not smile kan, U ataupun U terbalik. And the width of the graph. Okay. However, y-intercept remain unchanged. When A more than 0, the graph is U here, which passes through the minimum point. Okay, so ada yang paling bawah tu ialah minimum point. When A less than 0, the graph is masam, which passes through the maximum point. Okay, for graph A more than 0, for example, A is equal to 1, the value of A is larger than 1, the width of the graph decreases. Okay, conversely, when the value of A is smaller than 1, okay, approaches 0, the width of the graph increases. Okay. For a graph A less than 0, for example, A is negative 1. When the value of A is smaller than negative 1, let's say A is equal to negative 2, negative 3, negative 4, and so on, the width of the graph decreases. So, makin kecil lah graph tu. Okay, conversely, when the value of A increases from negative 1 and approaches 0, the width of the graph increases. Okay, if the value of B changes, okay, the second row, the change of the value of B only affect the position of vertex with respect to the y-axis. However, the shape and the y-intercept are unchanged. When B is equal to 0, the vertex is on the y-axis. Okay. For the graph A more than 0, when B more than 0, the vertex is on the left side. So, ialah the graph on the left. Okay, when B less than 0, the vertex is on the right. Okay, dia ke kiri ke kanan. For the graph A less than 0, when B more than 0, the vertex is on the right. Okay, so kalau graph masam, okay, kalau B more than 0, dia belah kanan dulu. Okay, kalau B less than 0, so dia belah kiri. The vertex is on the left. Okay, if the value of C changes, change in the value of C only affect the position of graph either vertically upward or downward. Okay, the shape of the graph is unchanged. Okay, example 1. Okay, the diagram shows the sketch of the graph for fx equal to x squared plus 1, where a is equal to 1. Okay, the general, you should know that the general function, the general form is, okay, fx is equal to ax squared plus bx plus c. Okay, so here the value of a is 1, b is 0 because there is no value of x here, plus 1. So 1 is referred to the value of c. Yeah, okay. Make an analysis and a generalization on the shape and the position of the graph when the following value change, hence sketch the graph. Okay, the value of A becomes 2. So from 1, it becomes 2. It become the value increase. What happened to the shape? Okay, and A2 from 1 becomes 1 over 2. So it becomes smaller. So what will happen? And lastly, since B is equal to 0, so we observe a C. The value of C becomes 3. What happened if the value of C increase? So let's observe the solution. So the first one, when A changes from 1 to 2, the width of the graph decreases. Okay, the y-intercept does not change and the vertex is on the y-axis. Okay, so this is the blue one. The blue one is the new one. So the red one is the original one. Okay, so fx equal to x squared plus 1. So ini yang dot merah ni. Okay, when A increase from 1 to 2, so dia makin mengecil. Okay, so dia punya kelebaran makin mengecil, so dia ke dalam. So this is the new one. Okay, the blue color. Okay, for A2, when A change from 1 to 2, so the value of A decrease the width increase. The y-intercept does not change and the vertex is on the y-z. So this is the original one. This is the original one. Okay, asalnya. So when A decrease, makin berkurang, makin kecil. So size width dia makin besar. So dia makin besar sikit lah. The blue color. Okay, so this is graph fx equal to 1 over 2x square plus 1. Okay, we continue with example 1b. Okay, what happens if the value of c becomes 3? From 1, it increase becomes c. Okay, the solution. When c changes from 1 to 3, the shape of the graph remain unchanged. The only change is the position, which is dia punya y-intercept. That is, graph move 2 unit upward. Okay, from 1, it becomes 3. Why the y-intercept here? Okay, so this is the red color is the original graph fx equal to x square plus 1. So now if it become x square plus 3, so dia naik atas lah. So y-intercept we mark as 3. The blue one is the new graph. Okay, so please do this exercise. What happen if the value of A, B and C change? So this is the original graph. Okay, please do in your exercise book and you can check your answer later. So this is for 1A, 1A2 and 1B, and this is C. Okay, relating the position of the graph of quadratic function and the types of root. So you have learned types of root in subtopic 2.2 by Miss Hatiin. Okay, so discriminant b square minus 4ac. Okay, types of root and the position of graph. Position of graph, if graph senyum ataupun graph masam. Okay, when types of root b square minus 4ac. Okay, types of root is two real and different root. Okay, the graph will intersect the x-axis at two different points. So this is the shape if b square minus 4ac more than 0. So ada dua intersection 2 point. So ni kalau graph senyum a more than 0. Ni graph masam a less than 0. A tu negative. Okay, second one, if b square minus 4ac is equal to 0, discriminant equal to 0 means there are two real and equal root. Okay, the graph touch x-axis at only one point. Okay, so since dia ada equal root. Okay, so this is what happened when our graph is a more than 0, graph senyum. Okay, a positive, so dia hanya akan touch dekat x-axis dekat satu point sahaja. Nilai a is equal to nilai b. Alpha is equal to beta, sorry. And second one, this is when a less than 0. Graph a ialah graph masam, negative. Okay, it only touch at one point. Okay, alpha is equal to beta. And lastly, when the discriminant is less than 0 means no real roots. The graph does not intersect at any point on the x-axis. So graph tu akan graph terapung lah. So if a more than 0, macam ni je. So it does not touch. There are no intersection. This one also terapung kat bawah. So no intersection of x-axis. Okay, now let's move to example 2. Determine the types of root for each of the following quadratic function when fx equal to 0. Then sketch the graph and make generalization on the position of the graph at the x-axis. Okay, so this is the first quadratic function fx equal to 2x squared plus x minus 5 and b fx equal to negative x squared plus 2x minus 1. Okay, so the solution. Okay, so you need to remember that if you want to do this question, discriminant is equal to b square minus 4ac. So you have to observe the types of the roots, and then you can only know how to sketch the graph. Okay, so given here f is 2 here, and b is here 1, and c is -5. Okay, put into the formula b square minus 4ac, we can see that the answer is 41. 41 is more than 0. Okay, remember the previous slide? If our discriminant more than 0 means that there are two real and different roots. Okay, the graph will intersect at two different points. Okay, so we have to mention that quadratic has two real and different root. So if two real and different root means that the graph is a parabola which has the minimum point, graph senyum, and intersect the x-axis at 2 points. So like this. Okay, we can see that this is x-axis, and then graph senyum, and we have a minimum point here. Okay, and also we have two intersection here, two different root, the first root and the second one. Okay, when if discriminant more than 0, please remember this. Okay, second example for B. We can see that the value of A is equal to -1, B is 2, and lastly C is -1. We put into the formula of the discriminant, and then we'll get 0. So discriminant equal to 0, please refer the previous slide, means that two real and equal roots, the graph will touch the x-axis at only one point. Okay, so the graph quadratic function has two real and equal root. Since a less than 0, so the graph must sum yang either maximum point and will intersect the x-axis at only one point. Okay, so this is the graph. Graph must sum. Okay, and intersect x-axis at only one point. This is the two equal root here. Okay, example 3. So find the values of m such that x-axis is the tangent to the graph of quadratic function fx is equal to m plus 1x squared plus 4 m minus 2x plus 2m. So tangent means that it touch at one point only. Okay. This is the solution. The graph of quadratic function fx m plus 1x squared plus 4m minus 2x plus 2m such that the x-axis is the tangent to the graph means that the function has two real and equal roots, since it only touch at one point. So if we have a graph parabola and the x-axis only touch at one point here, so means that here this is equal root. Okay, so for two real and equal root, in the previous slide you have learned that the discriminant is equal to 0. So if you want to solve this one, so you have to determine the value of a, b and c. So the value of a here, sorry, a, so the value of a is equal to m plus 1, b is equal to 4 m minus 2, or just expand the bracket, so it become 4m minus 8, and lastly our c is equal to 2m. Okay, so substitute into the discriminant equal to 0. So 4m minus 8 square minus 4m plus 1, and our c is 2m equal to 0. Expand these two bracket becomes 2 bracket 4m minus 8 and 4m minus 8. Minus, I expand this bracket first, so it become minus 4m multiply with 2m, 2m square plus 2m equal to 0. So I expand these two bracket, it becomes 16m square minus with 4 times negative 32. So negative 64m, negative 64m plus with 64 minus with 8m square minus with 8m equal to 0. And then solve 16m minus 8 becomes 8m square. Negative 64 you minus with 8, you will get negative 72m. Sorry, 72m plus with 64 equal to 0. And you can substitute this into your calculator, and you will get m is equal to 1 or m is equal to 8. But please remember that you cannot simply write your final answer like this without do this one factorization here. So put back in the bracket equal to 0, m, so it become m minus 1, and this one m minus 8 equal to 0, and you will get this answer. So this is your final answer. Okay. Okay, continue with example 3 for B. Find the range of values of k if the graph of quadratic function fx 2x squared plus 5x plus 3 minus k has no x-intercept. So this is the keyword. Okay, so if the graph of quadratic has no x-intercept, which means the function has no real root. So if no real root, the solution means that the discriminant less than 0. So as usual, determine the value of A is equal to 2, B is equal to 5, and C is equal to 3 minus K. Okay, substitute into the formula, you will get B is 5 square minus 4, A is 2, and our C is 3 minus K less than 0. Okay, so this one you will get 25 minus with so this one you can expand these two bracket first. 4, 2 times 3, 6 minus 2k less than 0. So 25 minus 24 plus with 8k less than 0. So 25 minus 24, 1 plus 8k less than 0. So 8k less than negative 1. So k is less than negative 1 over 8. So this is the range of the values of x if there are no x-intercept. No x-intercept means discriminant less than 0. Okay, now we continue with the example 3 for question C. Find the range of value of p if the graph of quadratic function fx, x squared plus px plus p plus 3 has two x-intercept. So this is the keyword. Okay, the solution. So if this graph quadratic function has two x-intercept, means that it has two real and different root. Okay, so for two real and different root, the discriminant more than 0. Okay, so as usual, determine the value of A is equal to 1, B is equal to P, and C is equal to P plus 3. Okay, so substitute into the discriminant here. So B square means P square minus 4A1, C is P plus 3. More than 0. So P square minus 4P minus 12 more than 0. So solve this one, you can use calculator. So the calculator will give two value, which is P is equal to negative 2 and P is equal to 6. Okay, so if you want to find the range of this quadratic function, so you have to solve using graph. Okay, if you still remember in 3.1, if you want to solve quadratic inequality using graph method, so you have to draw graph. Let's say P square means that graph senyum. Okay, graph senyum. So intersection here is -2 and here is 6. So since the inequality sign is more than 0, means that you have to take the above part, which is here. Okay, so you will get here, actually this one is okay, ke kiri kan, nombor dia makin mengecil. So P less than -2. While this part yang sebelah kanan punya, so 6, so di belakang 6 makin besar kan. So P more than 6. So this is how we solve inequality. So this one, okay, continue. So you will have P plus 2 in bracket. Okay, these two value, okay, cikgu letak dalam bracket. So P equal to 6, kalau letak dalam bracket, it become P minus 6 more than 0. Okay, so how to solve this quadratic inequality? So using graph method, ni cikgu dah solve. So our range will be P less than -2 or P more than 6. So inilah graph yang asal tu. Ni cikgu lukis kat sebelah ni. So ni. So we have to take this part and this part. Okay, the positive since inequality kita ialah more than 0. Okay, so then please do some practice exercise 2.7, question number 1, 2, 3 and 4. For question 1, please do all of it. For question 2, 3 and 4, you can just do question A only. Okay, B, you don't have to do for question B. And check your answer 1A, B and C. For question 2, 3 and 4, you can refer this answer only. Okay, making relation between the vertex form of a quadratic function fx equal to ax minus h square plus k with other forms of quadratic function. Okay, so the vertex form is a quadratic function in the form of fx equal to ax minus h square plus k, where a, h and k are constant. The vertex is hk. Okay, and it is symmetrical about the line x equal to h. So inilah vertex dia yang inilah vertex. Okay, when a more than 0, the vertex is the minimum point. So kalau graph senyum, vertex kita ialah minimum paling bawah. Kalau lah graph tu ialah a less than 0, negative value, so the vertex is the maximum point. Okay, macam ni lah graph masam. So kita punya vertex ialah maximum, sorry. So ni ialah maximum point. Okay, other than vertex form, the quadratic function can be written in the following form. Okay, general form. This is the usual form that you learned before. Fx equal to ax square plus bx plus c, where a, b and c are constant, with vertex at the point of b negative b over 2a. Okay, f, okay, negative b over 2a, and asymmetrical about the line x is equal to negative b over 2a. And second one is intercept form, which is ax minus p x minus q, where a, p and q are constant. P and q are the roots or x-intercept for fx. Its vertex is at the point p plus q over 2 and y f p plus q over 2, and symmetrical about line x equal to p plus q over 2. Okay, you can change from vertex form to general form. Okay, from vertex form here, this is vertex form. Change into general form by using expansion. So expand the bracket here, and then it will become general form. So from general form, if you want to do intercept form, so you have to do factorization or formula. Okay, formula you learn in 2.1. And intercept form, you want to back to general form, so you can do expansion. Expand this bracket, so you will get general form. And then from general form here, if you want to do vertex form, so you will need to do completing the square. Do you still remember how to do completing the square? Okay, let's recall after this. Okay, example 4. Express quadratic function, this one, in the intercept form, where a, p, and q are constant, p less than q. Hence, take the value of a, p, and q. So now, this one, we want to change into an intercept form. So this is the intercept form. Okay. So solution, how to solve it? Convert the vertex form of a quadratic function. So from the vertex form into the general form first, before we can change it into intercept form. We can direct vertex form to the intercept form. So we have to do one by one. Okay, general form first. Okay. So this is our quadratic function. Write it here. Fx is equal to 2 in bracket x plus 9 over 4 square minus 1 over 8. And then you can expand this to bracket. It will become 2 x plus 9 over 4 x plus 9 over 4 minus 1 over 8. Okay, expand these two, you will get 2 in bracket, okay, x square. So I expand this first. X square plus 9 over 2x plus 81 over 16. Okay, minus 1 over 8. And then expand 2 with the bracket. So I will get 2x square. 2 multiplied with 9 over 2 becomes 9x. And then solve this one. 2 in bracket 81 over 16 minus 1 over 8. So you will get 2x square plus 9x press the calculator plus 10. Okay, this one you can press your calculator. So the calculator will give two answer, which is x. Okay, I write it above. Okay, x is equal to negative 5 over 2 or x is equal to negative 2. Okay, but we don't want direct this is the answer, so we have to put it into bracket, so it will become this one. How to move into the form, into the bracket? So multiply with x, it become 2x. So 2x plus 5 and x minus 2 become x plus 2. Okay, in this case, this is the general form. Okay, so we already changed the vertex into the general form. So now from the general form, I want to change into intercept form here. So if we observe intercept form, there are two brackets and the value of a outside. So make sure that the value of x, the coefficient is equal to 1. But here, this one, the coefficient, there are 2 here. So we have to take out this one. It's okay, already fine. Okay, the value of x, the coefficient is already 1. So we have to take out these two outside the bracket. So if we take out, so it will becomes 2 in bracket x plus 5 over 2. Okay, x plus 2, and this is just the same. Okay, so now this one is intercept form. Okay, so what is the value of a? So a here is equal to 2. What is the value of b? P here. P is here. And this is Q. Okay, so P, if you observe here in the formula, it is negative. So you can just direct take the value of P is 5 over 2. So means that the value of P is negative 5 over 2. And the value of Q is negative 2. Okay. It's okay. Okay, the alternative method you can use here. I don't want to teach you the alternative method, so you can refer by your own. Okay, example 5. Express fx equal to negative 3x squared plus 2x plus 1. So this is a general form. Okay, as fx equal to ax minus h squared plus k. So this is vertex form. So in previous slide, I already tell you if you want to change from general form to vertex form, so you have to do completing the square. Okay, so how to do completing the square? So let's solve. Okay, the solution. Okay, so this is the general form. So before you want to do the completing the square, you have to make sure that the coefficient for x square is equal to 1. So now the coefficient for x square is negative 3. So you have to divide by negative 3. Okay, factorize the negative 3 outside so that the coefficient become 1 x for x square. So here I write the solution. So fx is equal to, so negative 3 outside the bracket, so it become x square. Okay, sorry, x square, okay, plus 2, sorry, this one negative 3, so it should be negative 2 over 3x, okay, plus 1, so negative 1 over 3. Okay, take out the negative 3 outside, factorize negative 3. Okay, and then this one, if the quadratic equation here, the coefficient is already 1, and then the second step for completing the square, you have to add and subtract the coefficient of b here. You still remember this one? Add and subtract. So how to do that? So negative 3 in bracket x square minus 2 over 3x plus, you plus the first one, you have to plus. Okay, so b is negative 2 over 3, right? So if b over 2, it becomes negative 1 over 3. Okay, so now you have to add and subtract. So I add negative square. Okay, square. Okay, so I add b over 2 square. So negative 1 over 3 square. And then this one I continue, negative 1 over 3. Second step, you have to minus with b over 2 square. Okay, which is negative 1 over 3 square. Okay, solve this one. Okay, then negative 3. Okay, this one you can just take this into the bracket. So x minus 1 over 3 square. And then solve this one. Press the calculator and you will get 4 over 9. Okay, and then this one you have to expand negative 3 here. Okay, with this bracket. So I expand negative 3 x minus 1 over 3 square. Okay, negative 3 multiply with 4 over 9 become negative 4 positive 4 over 3. So this is actually in vertex form. Okay, you can compare the vertex form here. Okay, so means that our A is equal to -3. Okay, H is equal to 1/3. And lastly, our K is equal to 4/3. Okay, so brainstorming. By using completing describe method, show that the equation of the axis of symmetry is equal to x minus b/2a. So you can solve by your own. Okay, so next, please do exercise set practice 2.8 for question number 1, question number 2, and also question number 3. And you can check your answer later here, question number 1, 2, and also question number 3. Please do, because if you do the exercise, then only you can know how to change from a vertex to general form, and then from vertex to general and intercept form, and so on. Okay. Okay, so for conclusion here, what we have learned today, so there are three form. First is general form. So this is general form ax square plus bx plus c. Vertex form here a x minus h square plus k. And lastly intercept form fx equal to ax minus b x minus q. And then for general form, okay, the effect of changes. Okay, you have learned in the beginning for a more than 0, so our graph shape will be so graph like this. So for a less than 0, so graph shape is macam ni, asam. Okay, so the effect of changes for a more than 0, let's say for a more than 0, if b less than 0, more first. If b more than 0, so graph will shift to left. While for b less than 0, graph will shift to the right. And vice versa. Vice versa means that if we have a less than 0, so it is vice versa. Sebaliknya. Okay. So, and then lastly, if C increase, so our graph will shift upward. Upward. Okay. If C decrease, the value of C decrease, the graph will shift downward. Downward. Okay. Okay, so that's all from me. Thank you. So in the next class, we will still continue subtopic 2.3 quadratic function. Miss Hatiin will proceed with subtopic 2.3.4 until 2.3.6, solve the problems. Okay, in the next class is the last lesson for this chapter. Okay, that's all from me. Thank you and bye bye.